Welcome everyone. My name is Boyan and today we are going to talk about REST. Let me just quickly see how many of you are using REST, created REST APIs. Right? Most of you. Great. That's nice. So probably you've come to the right place to be now. REST is dead. Okay. I see some of you are very confused about this. Well, this is at least what some people are claiming, or at least have been claiming in the past couple of years, that REST is not something that we are needing anymore. Why is this? If we take a look at the different technologies that have emerged and that we as engineers have started using, some people say that we don't need REST anymore because of those technologies. Which are they? Let's take a look. One of them, WebSockets. We know WebSockets used for next to real-time communication between a browser and a server. And how do REST get outdated because of WebSockets? Well, there are some libraries that use WebSockets to dynamically, say, update your HTML, so you don't need things like Angular or React anymore and things like this. And there are libraries doing that. Then on the backend side, we have something like a Sync API, which is really a set of tools and frameworks to build better microservices out there. And it's really like a protocol specification, things like this, so that we can build better microservices and we don't need REST anymore. Another thing, gRPC, again, different protocol for communicating mainly between microservices on the backend side, very optimized. Again, not needing REST here. And then GraphQL, of course, the thing that we all know. Why? Well, it optimizes the way we work with data, so REST is not needed anymore. At least this is what many people claim. Is this really the case? To answer this question, let's do a quick historical lesson to see when REST emerged and why. If we go back to 1981, what we had at this point was something called RPC, Remote Procedure Call, and what it really did was simulating that you call a function, but this function resides somewhere else on some other server. This is what it really did. But it was very powerful. And later on, we had something like Corba, XML variant of RPC, etc. And around the year of 2000, we had something called SOAP. Who of you have used SOAP? Okay, great. Well, SOAP was king back then. Everything was built around that because people realized that they could build different services. You could call a service, get some result, do some really nice stuff. And then later on, REST suddenly started to get popularity, like REST and JSON. And then all different technologies based on that started emerging. To understand why REST really won at that point, we need to really understand what was the situation back then. As I saw, most of you have been using SOAP, so they are familiar with this. Who of you know what is this tool? Do you remember the name? Yeah? SOAP UI, exactly. That's the tool. That was one of the main tools to test services, SOAP services. And for you that don't know what SOAP was, it was basically an XML message passing variant. So you build XML messages, you send it, and you get a result. It did look like RPC in a way. The good about SOAP was that it was very extensible. It was really a set of different standards about, let's say, security, discoverability, and things like this. So that's why it was so popular back then. However, at some point, browsers started getting more and more smart. So we wanted to do more things with JavaScript. And because at this point, JavaScript was not giving us that options to build dynamic web applications, some companies did something like this. Is there anyone that can guess what this is? Anyone remembers that? All right. Well, this is something built by Microsoft back then. It was part of their so-called ASP.NET web pages. What Microsoft did was, hey, we can build desktop applications by just dragging and dropping different components like buttons, input fields, etc. So we want to transfer this into the web. The problem is that in the web, things are stateless, right? We need something to maintain the state between the browser and the server. So what they did was, hey, we can send this state on every request between the client and the server. That's why they built this called useState, which is really a serialized version of your input fields on the web page. That's how the server knows how to render the HTML back. So this was their way of doing that, right? Very, very primitive. When REST came, it did allow us to make web applications very easily. Because back then, most of the applications, let's be honest, they were really crude applications. You had data residing almost 100% in a SQL database, and you wanted to get this data into the web, right, and do some modifications to that. So most of the applications really were crude applications, and REST made it very easy for us to work with these applications. That's why REST and JSON started gaining popularity. And this here is an example taken from Postman, which is the modern alternative of SOAP UI, say, to allow testing and working with REST and not necessarily services. So according to them, their research, REST is still one of the most used way of creating services out there. Of course, we can see webhooks, GraphQL. We can even see SOAP UI. There are still many services built on that, on SOAP, and even Corba. Very, very legacy systems that are still alive. Now, Amazon CTO said in one talk, APIs are forever. What does that mean? Once you create an API and you start using it from web client, mobile application, maybe desktop application, maybe third-party, whatever application, you have clients using your REST API. And this will create some trouble for you because you need to maintain this API forever or until your company exists, because you know that many startups recently have a very short lifespan, but still you have to maintain this API. Just because something is forever, it doesn't mean it needs to be static. We need to know how to evolve our APIs. Technologies are changing, things are changing. We need to get used to that and adapt and evolve our APIs. And that's why we have these challenges that we are going to talk about today. I like this quote, this is the IT version of the Hippocratic Oath of APIs here, which says, first, do no harm. What does it mean? Let's take a very, very short example. This is a simple API. I know there are many coffee lovers here, especially in the morning. So this is a very simple REST API that gives us information about a coffee. Now it's an Ethiopian coffee. You know, it has ID, roast level, it has rating. This is a very, very simple example. Say this is what you built for a web application. And 1 week after we build this, the product manager comes to you with a designer and say, hey, look, we need to display also the origin of the coffee in our web page. And then you say, great, sure, I'll just add an origin here, and there we get it. You can just get it and display it on the web page. Your work's done here. But then, after some more time, they come again and say, look, now you give us the country, but we also need to show the region of this coffee, right? And then you start thinking, okay, great, then I'll just replace this and I'll show you the country and the region, right? Now you should be happy, right? The problem now is that if you only have one web application that you kind of synchronize with your API, you could do that. However, imagine that you also had a mobile application showing the same information using the same API. Then doing this change will automatically break your clients. Your users will become angry, hey, this is not working. I mean, what is this information now? Until they, of course, upgrade. But you know that using mobile applications is a bit tricky because of the updates we need to do. And we hate doing updates of the applications. That's why we need to talk about versioning. And probably most of you have heard about things like semantic versioning. Yeah, most of you, great. Where we have like major, minor, patch version, like basically three version numbers. I think what we mostly do is this one, right? This is sprite versioning, where we update, like the first one is only update when you're really happy. Yes, this is it. This is the coolest version of our product right there. And then the last one is always updated 1 to 3 until it gets to 1 million, etc. But we need to talk about versioning. And Versioning is mainly something we apply to mobile application, desktop applications, because it's something static. It really describes a set of functionality that you as a client expect from a certain application at a given time. In the web, this is a bit different because things, as we speak, they evolve. They are not constant. So let's see some examples of what we can do in the web. This one is I think, one of the most popular way to version your APIs. Anyone doing that? Like versioning? Yeah, great. I think this is really one of the most popular way to version your API. You basically, in the URL, you would put like v1, v2, etc. Why is it so simple? First, because in the URL, you get this. If I give you a URL to my API, you can see which version you're going to use. Very, very easy. Also works pretty nice with the browsers, with the caching. Once you do GET request, it will cache the responses pretty well. Of course, the URL becomes a bit ugly. You have to put those numbers there. It doesn't look that nice anymore, but that's how life is sometimes. And the problem is that the moment you introduce a new version, you have to, of course, do some maintenance of the code out there. So it becomes a bit tricky to add new code and increase the versions there, because if you want to do this more often, then at some point you end up with probably v1000 here in the URL, which is probably not that nice. A different way of doing that is using the query string. So instead of putting the version into the path, you would put it into the query string parameter. Almost the same, but a bit trickier to implement on the server side. Why? Because, well, using the path, it makes very easy to give it to, let's say, a gateway or load balancer or any server in between your plans and the actual API server to do the routing there. So it could be a bit tricky there. And query strings are kind of, in many loggers, they would omit the query string. So you get some tricky situations out there. So this one, I don't think it's that popular. Another way, which is also not that popular, but is actually used, using the header. What does that mean? Well, the URL stays the same as it is. We have coffees, 1, 2, 3. And then you would need to pass a custom header saying, hey, I want version 1.0. This is one way. Or if you want to be more RESTful, in a way, you could use something called content negotiation. This is actually the REST way of working with different versions, using the accept header, where I would say, hey, I accept versions of this kind. This is very cool because it's really more RESTful to do it. URLs stay the same. However, it becomes a bit tricky to test, right? You can't just open this in the browser. You can't do any kind of hacks with the browser dev-utils. You really need to use something like Postman, where you send this header with each request you do. So a bit more trickier there. Then you get some issues with the caching, especially if you do a lot of changes between the response types, right? So you need to be very careful how you design your caching strategy if you do these kind of things out there. And then on the backend, this will be a bit more trickier to implement because you need to parse the header. You probably have some more complex logic to route this one. But it is used and it is possible. Microsoft mainly uses it, but there are also some other companies. And now when we say routing, I think this is one of the most popular way to route this. What does it mean? You have something like an API gateway or a central server that accepts the requests from your clients. And then based on the version, they would probably route this maybe to different Lambda functions, different servers, depending how you want to structure. If you have very complex API, you might want to separate the versions, living on separate machines. So this is something that you are going to do probably. If it's something simpler, then you might put all the code on the same server, and then you could do something like this, using this an example with Node.js and Express, saying that, hey, based on the request, I can just route you to the correct piece of code that would handle this version. Very, very simple way of doing that. Now, no matter which strategy we choose, this is inevitable. We are going to have to maintain a lot of code because with each version increment, we are still going to maintain the past versions. And let's be honest, the data is almost the same between the versions. What we usually change when we introduce new version is the way we handle this data, the way we talk to that, edit it, etc. But it's really kind of the same out there. We need to see how to be better at maintaining this. And one of the strategies is, of course, don't introduce new versions, right? How can we avoid introducing new versions? One of it is to be backward compatible. And by being backward compatible means that we can add things, we cannot remove things. And we should be very careful when changing things. Now, there is one caveat here. Most clients, when they work with REST APIs, they're fine with taking the response and doing whatever they want. But some of those clients might be more strict, meaning that they would expect the exactly same schema of your response, JSON response, otherwise they would fail. This is not very nice to do, but your only way to do this is first, of course, if you maintain the client as well, you can change this one. However, if you don't have control over who your client is, you need to know it. You need to monitor your traffic, see who is using your API, and maybe communicate with them. Be proactive, and then let them know what is going to happen. But anyway, adding new stuff is usually on the safe side. Of course, you need to be careful with things like enumerations, pagination, so that you don't change the semantics out there, because this is also going to be a breaking change. Now, we as developers like when things are static. We get a library, we start using it, and at some point we would start inevitably getting messages like this that we need to upgrade to a new version or change a method because this method does not exist anymore or is going to be deprecated. But deprecation is really a strategy to get rid of all this old stuff that you don't need anymore. And this is something that we need to consider very seriously when working in multiple versions. One of the very, very easy strategy to use here is say, well, at some point you might include in your responses a special header saying, hey, this API will be deprecated at this date out there. But again, in order for this to work, you need to know your clients. You need to monitor the traffic, maybe by version, and see who is using your application, who is using your API. Unfortunately, some big, say, enterprise companies require you to sign a contract that you maintain this API for 5, 10, 15, even 20 years. Then you're probably stuck with this. You can't just replace and deprecate this API. But you can be proactive. You can contact them, offer them alternative, which is very important, because they need to know what their options are. And maybe help them. Of course, if they're a very big client, you would probably need to spend some resources on helping them upgrade. At some point, of course, you can just remove the old code and be happy. So far, we have talked about a single resource. Like the example we saw was a single resource. But let's be honest, in the real world, we are dealing with multiple resources that are connected in between. So this here is a very simple example I made up, like extended the coffee's example that we saw earlier. A database schema of the coffee, and then we'll have some probably importer company, we have some regions, coffee flavors, etc. This might look something like this. It could, in reality, it will be much more complex than that. But now that we have all this information, how are we going to deal with that? The rest way to access information is really make multiple requests. So if you want to get the coffee, you make one request. If you want to get more information about the importer, another request, etc. But the problem with this is that you might end up making really dense requests on a single page, which is not very optimal. Even with HTTP2, now that we have, this is not really very optimal. Especially if you do things like if you have a search page where you have multiple items, and for each search result, you need to do those requests. This does not work well, right? What can we do then? Well, one of the very, very simple things that we have done, and I have seen other people do, is doing something like this. You might include something like expand parameter in your query string, or include, or things like this. And I say, hey, here I want to get also the importer in this one, and then you get the information about the importer. Very, very simple, very practical. If your API is simple and you want to kind of increase the complexity a bit, only a bit, this could work for you. But this is not something new. Anyone remembers here or knows what OData is? Okay, very few people. Great. You are unlucky as I am. Because this is something that was invented by who? Oh, Microsoft again, because they love inventing interesting things. And this is still used. It is extension, or we can say framework over REST API that allows us to do things like filtering, pagination, sorting. It really resembles what you want to do with the SQL database, right? You have a table and you want to do all these things there. You want to give me the first 10 results, but sort them by name, etc. These kind of things. But you can do this within the REST. And this is how it looks like. It's really REST. It looks kind of ugly because they have their own IDs and things like that. But it's something still used, especially in SharePoint, if you're unlucky as I am to have worked with that. Then some of you might say, but hey, we have GraphQL. That's exactly why it was invented. And you might be true. Yes, GraphQL was exactly invented because of the problem of REST, of so-called overfetching or underfetching. You don't know what information you use, and it's one of the biggest challenges with REST APIs, designing the level of information that you work with. And GraphQL is indeed an answer. The question is, of course, do you want this? It is a new technology, something you need to maintain, and it will bring different problems to you, things like with caching, setup, maintenance, etc. So if you are building a complex API where you want to be flexible about the data fetching, GraphQL might indeed be a good solution for you. If you are just scaling up your API and wanted to expand it a bit, it might be an overkill. So you need to choose your victims here. Anyone have heard about something called HATES? Very few people. Great. This is not something popular. I mean, this long abbreviation means hypermedia is the state of the engine of the application state. So what do we have? We have application state and we have hypermedia. Hypermedia, we know links from HTML. These are the links. Application state is the state we work with. This is actually this is the REST way of doing links between resources, but it's not very popular, and for a reason. Let's see how this looks like in action. If we go to the coffee example we had before, what we do here is we'll just include this part of the links. So this is the hypermedia. For each request that we are going to make, we would have a link section giving us options what else we could do with that resource. So in this one, we would have the self. This is the link to the same resource. Then we have, if I want to get the importer, I would get the importer. If I want to order coffee, then I can have a link to the ordering coffee, etc. It really gives us a list of possible actions, what else we could do with that resource, the coffee in this example. If we compare this to HTML, this is a pure HTML. This is exactly how it would look like, very, very simplified. We would have the information about the coffee, and we would have anchors with the links about what else we could do with that. And then you might think, great, well, we are humans, we use HTML, right? We open the web page, we do visual things, and then machines, they would use the HATES because they will do kind of the same things as we do. Well, not necessarily. I decided to play a game with ChatGPT, and by the way, this is something that you could do yourself. I asked ChatGPT, hey, look, I will pretend I'm a web server, so you just make me HTTP requests. I will reply with the HTML code, and you have a goal. Your goal is to order coffee, right? And that's how we started. So you can see the first request is, hey, give me the coffee. And I said, sure, here is your coffee. Here are the links. Then what else? And then it said, oh, there is an order. I want to go to the order page then. Great. Here is the order page. Here is a form. So ChatGPT says, okay, this is a form. I can make a post request and order coffee with that form. Right? So ChatGPT can also, of course, understand HTML. They can also understand REST. They can understand anything that is structured because of the AI logic that they have inside. So HATES is really an API style of the way we process web pages. So the way we process web pages, Helios allow machines to do that. Well, then you say, but we saw an example that ChatGPT was working perfectly fine with HTML and things like web scraping. Why do we need Helios at all? You might be right, yes, that's true, it works. The problem with web scraping things like this is that they bring a lot of things for the LLM to process as a context, things unnecessary. It might confuse the LLM at some point. REST APIs are very, very specific. We have key values, that's it, and they are named. The key describes what the value is, so nothing really to get confused about here. So this is more really very specific context to what we can do here. It does reduce the ambiguity a lot. It does help the LLM to perform workflows. So you start with the resource, right? And then by having those links, you could explore what else I can do. Well, you want to do this, you want to get this information, etc. So you navigate the LLM of using your API, which is very beneficial in the world we live in right now. Now, at some point, you get, you post your API, and then it starts getting used by people, and at some point, and this has happened to us, come on, we have also played around and we have tried to get access to different APIs online. At some point, they discover us, unfortunately, and they block us. Rate limiting is a way to control who gets access to your API and when. Why do we need that at all? Like, why do we need to implement rate limiting at all? Well, one of the first reasons is really overconsumption. You probably want to control the rate of accessing your resources. It could be because you pay for this access to the cloud providers. It could be that there is some different, setup that you have. No, it could be different reasons. So you really want to control the access there. Then you probably want to mitigate some security threats, like by accessing this in a certain pattern. This could also lead to discovering some security issues. Or, of course, you want maybe to monetize your API, right? So you want to give, say, 10 free requests each month, and then after that you want users to pay for that. That's also a very valid reason. So all this way, control the frequency of your API, the use of your API. And how does this work for those of you who are not really familiar with rate limit? Very, very easy example. There are different strategies, but most of them are using the same principle, that you have some quota, saying each user has 5 requests per minute, and then if they try for this time span of 1 minute, if they make a 6 request, they'll be blocked, and then they need to wait until this time window increases. That's really how it works. Now, how do we implement this? Well, first, of course, we need to choose this quota and the algorithm we want to use that. But most of the algorithms, they do the same. They have this static quota that we apply, and that's it. Now, some past services used the status code 500 or 503 because this is how they signal that now you're rate limited. But now we have status code 429, so please, if you implement it now, use this status code. This is the standard to be used right now. But don't be surprised if you see some older services using 500 or something like this. And then now a good practice is to give your client an indication when they can call you again. You could include something like retry after header in the response, or to give them indication when. Otherwise, they might be spamming you more and more. So they might get blocked by, not by rate limiter, but for being a spammer, things like that. Then in the client, we could do the same. So if we make a request and then we get 429, then we say, great, if you give me indication when I can call you after this time has passed. Otherwise, your best bet is to use something called exponential backoff, meaning that you call with different intervals that increase with time. Don't do static delays, meaning try every second afterwards, because you might get blocked even further for that. So if there is no indication when you can call the API again, use exponential backoff. It's much better and more resilient in this situation. Now, this works for normal clients. However, LLMs are not normal clients. This here describes the pattern, the request pattern of some of the most popular LLMs that we have out there. The way they differ from the normal usage of us as developers making calls to some API, it would be that they might be very sporadic. At some point, the LLM might decide that they need to make a very, very large amount of requests to your API to achieve something. And you can see this burst of going up and down describes exactly this pattern. And this creates a big challenge for us as developers providing APIs, especially if we want our API to be used by LLMs, which is the case in most APIs nowadays. So what can we do there? Well, in order to be able to handle this traffic and this sporadic burst, we need to know our clients again. We need to see who is calling our API, and we need tools to monitor and do things like anomaly detection. Of course, we are going to use another AI tools for that, right? So use AI against AI. That's how things are nowadays. But we need to be proactive and monitor the traffic and see who is using our API. And then, if you decide that this is probably allowed traffic, then you should allow it. So instead of the traditional way of using a static quota for the rate limiting, we need something like adaptive quota. And this adaptive rate limiting is really a set of principles and tools to provide more dynamic way of handling requests to your APIs. But in order to apply this, you need to have very good setup of monitoring the traffic and knowing who your clients are to give them better options. Now, if you go back to the first question, it's really press that. We as developers often like ditching old technology and just going in for the newest shiny thing on the block. But what is often the case is that we forget that things are there for a reason, and they are going to be used as a fundament for next generation of APIs or technology out there. Now that we are living in the era of AI and LLMs, we need to adapt for that and change our way of writing APIs, providing APIs, consuming APIs, so that it matches the new requirements. Now, there is, anyone has heard about MCP, Model Context Protocol, a few people? Well, now that we have so many LLMs, they need to be talking to all these APIs out there, or this information. Could be a database, could be a REST API, could be a SOAP API if you want, anything. And as we saw, yes, LLMs can work with HTML, they can work with APIs, but this is not optimal, because these can, like things that are outside their context, not needed for their goal, it might confuse them. So we want to be very, very specific what we give them so that they know this is what I need to do, and we decrease the chance, the possibility of LLMs making a mistake. So Model Context Protocol is, again, like a set of tools, we could say a framework of exposing APIs, resources, to LLMs in a certain way. So it's really like a wrapper, you could say, for that. So we have choice. We can either, of course, expose our API directly, or we can wrap it in an MCP, but we are most probably going to allow the LLM to use it. And we need to consider all those challenges that we have with the traffic burst, with the different, if you say time of making the request, different manner, because LLMs does not behave as we are. And even there are different, malicious botnets that simulate the traffic of a normal user, and suddenly they start doing DDoS attacks, things like this. That's why it's very important to monitor our APIs using appropriate tools to ensure stability and availability for our clients. So if we can kind of summarize this, what can we say? Well, we have APIs. But who is using the APIs? We are using the APIs, developers. However, machines and LLMs nowadays are most probably going to use the MCP. This is their standard way of doing that. No matter how we choose to expose our API, we need to be very considerate about these implications. Now, if we answer the question, is REST dead? No. REST is the fundament of building applications in the web nowadays, and all new technologies are going to use REST today and probably tomorrow. We just need to adapt for the new era. Thank you so much.